Louis Pasteur, born December 27, 1822, in Dole, France. He was born to parents John Joseph and Janine Pasteur. He was a middle child with 4 siblings and came from a family of leather tanners. In his early education, Pasteur was considered an average student, only showing talent in his art. Pasteur didn't start to show interest in science until the later years of his education at Bescanon College Royal de la France. In 1840, he earned a Bachelor of Arts degree, and in 1842, he earned his Bachelor of Science with honors in physics, mathematics, and Latin. In 1843, Pasteur attended École Normale Supérieure in Paris, eventually becoming a teacher's assistant to Jean-Baptiste André Dumas. During that time, Pasteur was researching crystallography, optics, and chemistry. He earned a master's degree in science in 1845, then his doctorate in science in 1847. In 1848, a few months after receiving his doctorate's degree, Pasteur was studying the properties of crystals formed in the process of winemaking. He discovered that crystals occur in mirror image forms, a property known as chirality. This discovery became the foundation of a subdiscipline of chemistry known as stereochemistry. He then accepted the position of professor of chemistry at the University of Strasbourg. In 1849, he started to attempt to resolve a problem with the nature of tartaric acid, a chemical found in the sediments of fermenting wine. He found another compound called parataric acid, which was also found in wine sediments and had the same composition as tartaric acid. While most scientists assumed that the two acids were identical, Louis observed that parataric acid did not rotate plane polarized light. He concluded that although the two compounds have the same chemical composition, they must have different structures. While looking at the parataric acid under a microscope, he observed that there were 2 different types of tiny crystals. While they had looked almost identical, they were in fact actually mirror images of each other. He then separated the 2 crystals into 2 piles and made solutions of each. He observed that when the polarized light passed through, each of the solutions rotated but in the opposite directions. Therefore, when the crystals were put together in this solution, the effect of the polarized light was canceled. This experiment established that you couldn't just focus on the composition, but also had to look at the structure and shape to understand how a chemical behaves. This led to the field of stereochemistry, and he was awarded the Rumford Medal in 1856 for his discovery of the nature of racemic acid and its relations to polarized light. During his first years at the University of Strasbourg, a young Louis Pasteur met Marie Laurent, the daughter of the university's rector. Their bond grew, and on May 29, 1849, they were married. Together, they had 5 children. Unfortunately, only 2 survived beyond childhood. The others were lost to typhoid fever. In 1854, Pasteur was appointed professor of chemistry and dean of the science faculty at the University of Lille. 2 years later, a request from a student's father would set him on a path of discovery. The father, trying to ferment beetroot into alcohol, ran into an issue with the process. At the time, fermentation was believed to be a purely chemical process, sugar transforming into alcohol and nothing more. But Pasteur didn't quite believe that. In 1857, he demonstrated that a microscopic plant was responsible for the souring of milk, a process now known as lactic acid fermentation. He proved that living cells, yeast, were the agents behind the alcohol production, and that unwanted microorganisms from the air were the culprits behind the spoilage. Through experimentation, Pasteur found that these microbes could be destroyed by heating, an approach we now know as pasteurization. For his work, he received the Montyon Prize in 1859, awarded by the French Academy of Sciences. In 1861, Pasteur published his germ theory of disease, stating that microorganisms, what we now call germs, are the cause of many illnesses. Before his theory, people believed in spontaneous generation, suggesting that life could arise from non-living matter. Pasteur conducted experiments using a specially designed swan neck flask. His results showed that microbes entered from the environment, not from spontaneous generation. This was done by heating up water in the flask until boil for a few minutes until steam escaped from the open end of the flask. Then while cooling, air entered the flask, deposited dust and germs on the first bend. His recommendations of sterilization led to a widespread advent of modern surgery. He was awarded the Jecker Prize in 1861, and in 1862 he was awarded the Al Humbert Prize. In 1865, France's silk industry went through a devastation. Pasteur had figured out that silkworms were being affected by two diseases: silkworm nosema and flasherie. Under a microscope, he noticed that the worms with nosema developed shiny corpuscles and showed that the disease was both hereditary and contagious. To stop this disease from spreading, he isolated the female moths to lay their eggs, and after laying eggs, he observed the female under a microscope. If he saw the shiny corpuscles on the female, he destroyed the eggs. Otherwise, he kept them for breeding. As for the flasherie, he introduced the specific terrain concept, which is the physiological condition of the infected host favoring outbreaks of the disease. But with a few hygiene rules, good ventilation, and quarantine of the suspected batch, it did the job to prevent contamination. In 1868, a severe stroke left him partially paralyzed. Yet, undeterred, Pasteur pressed on with his research. In the 1870s, Pasteur starts his work to solve a problem that farmers were having with their chickens. At this time, chicken cholera was having a devastating effect on the farms because this disease could spread through an entire farm within 3 days. In the process of culturing cholera microbes and injecting them into the test chickens, it was found that when injecting the chickens with the live microbes, after they had been previously infected with a weaker quantity of the microbes, the birds were unaffected. This led to his interest in coming up with a cure for anthrax, a disease that was harmful to sheep and cattle. In 1881, he successfully showed his vaccine for anthrax to the public. With his vaccine, more than 3.5 million sheep and 500,000 cattle had been vaccinated with a mortality of less than 1% within a decade. He then went to work on other diseases, such as swine erysipelas, childbirth fever, and pneumonia. In 1873, he was elected an associate member of the Academy of Medicine. In 1874, was awarded the prestigious Copley Medal for his work on fermentation. After his acceptance into the French Academy in 1882, he moved his focus onto rabies. On July 6, 1885, a 9-year-old boy named Joseph Meister was bitten by a rabid dog. With the child in critical condition, Pasteur took a chance and administered his newly developed rabies vaccine that had never been tested on humans. The boy survived. Louis was praised over his vaccine for rabies. Soon after, the Pasteur Institute was built in Paris to treat victims of rabies. By decree on June 4, 1887, the Pasteur Institute was opened in Paris. On November 14, 1888, following Louis Pasteur's successful international appeal for funds. More Pasteur Institutes were built around the world to help treat rabies and other diseases. Louis Pasteur passed away on September 28, 1895, at the age of 70 after suffering multiple strokes. He was laid to rest in a private crypt beneath his former apartment in the Pasteur Institute in Paris. As Louis Pasteur once said, "Gentlemen, it is the microbes who will have the last word."